Hi, this video is about inverse sine function. So when we deal with functions, to have an inverse, a function has to have one-to-one relationship, and f of x equals sine x does not have one-to-one relationship, because if you draw a horizontal line, you're going to have multiple values of x for the same value of y. However, if we restrict our graph, our domain, to only this portion here, then this part of the graph has one-to-one relationship. The reason we can do it is because of the periodic behavior of sine function. So the domain then is going to be from negative pi over 2 to positive pi over 2, and the range obviously is going to be from negative 1 to 1. So then when we do it for the inverse sine, the domain and range will switch. So the domain is going to be between negative 1 and 1, and the range is going to be from negative pi over 2 to positive pi over 2. This is what the graph of inverse sine looks like. So the domain is from negative 1 to 1, the range is from negative pi over 2 to pi over 2. Let's take a look at problems. What's the arcsine of square root of 3 over 2? So you think about what angle has a value of sine that's square root of 3 over 2, but the value of the angle has to be between negative pi over 2 and pi over 2. This value here is going to be pi over 3. What's the arcsine of negative 1/2? So what angle on an interval from negative pi over 2 to pi over 2 has a value of sine that's going to be negative 1/2? So that angle is going to be negative pi over 6. What about arcsine of negative square root of 2 over 2? That angle on an interval from negative pi over 2 to pi over 2 is going to be negative pi over 4. So this is pretty straightforward. So far, you just have to remember that the angle has to be on the specific interval. What about problems like this? So here we're trying to find an arcsine of pi over 10. So when you do sine pi over 10, it gives you some sort of a value, and then you take arcsine of that, you will get supposedly that same angle back. In this case, that answer is going to be pi over 10. What about arcsine of sine of negative pi over 5? If we apply the same logic, here's what you can think about. If these two things are inverses of each other, and they might be canceling one another, is this angle going to fall on the interval from negative pi over 2 to pi over 2? And the answer is yes. So the answer here is negative pi over 5. So this is usually where students begin thinking, oh, I know, I just cancel, one thing cancels the other and I'm going to get my answer. Unfortunately, that's not as simple as this. Let's take a look at this. So here we have arcsine of sine of 4 pi over 7. But unfortunately, 4 pi over 7 is greater than pi over 2, and you cannot use that. So then what do we use? Well, then you have to find another angle whose sine is going to be the same as sine of 4 pi over 7. Basically, if you sketch the unit circle and think about 4 pi over 7 is an angle located in quadrant 2, somewhere over here, right? That's 4 pi over 7. And that doesn't have to be exact. So if you think about this, we're trying to find the sine of this angle and then get arcsine, but that value for arcsine has to be on an interval from negative pi over 2 to pi over 2, and this definitely exceeds it. But if you look at this angle, remember the value of sine is related to our y-coordinate. So if you go across and come over here and do this, then the angle here, this angle here, and this angle, these two angles are congruent. So if you can find that angle, you can use it to find that angle. So what's the measure of this angle here? Well, this angle here is going to be the supplement of this angle. So if you do pi minus 4 pi over 7, that's going to give you 3 pi over 7. And the answer here is going to be 3 pi over 7 because this angle here and this angle here are congruent, and the measure of this angle is going to be the same as the measure of this angle. How about arcsine of sine of negative 8 pi over 8? Well, where is the angle negative pi over 8? The negative pi over 8, that angle is actually going to be in quadrant 1. But just like the previous problem, we cannot use that angle for our purposes because that angle, negative 8 pi over 8, is not in quadrant. I mean, it's in the right quadrant, but it's not the right measure of the angle, right? So what can we do? Well, we can look at this diagram here, which is why these diagrams are so helpful. You should realize that we are in the right quadrant, and all you need to do is find the measure of this angle. Well, the measure of that angle is going to be basically 2 pi. If you take this angle, negative 8 pi over 5, and you add 2 pi to it full revolution, you will be able to get the measure of the coterminal angle here, which is in quadrant 1, and that's going to be 2 pi over 5. So the answer here is going to be 2 pi over 5. And how about this one? So let's take a look. Negative 4 pi over 5 is an angle that's going to end up being in quadrant 3, and it's not going to work for us for sure. Somewhere over here is going to have this angle. So we're going to use the same logic we used in example 6. We're going to say, okay, let's find another angle whose sine is also going to be the same as sine of negative 4 pi over 7. So we're looking at the same y coordinate. So right here. Right? And what we need to do is we're going to look at the measure of this angle. It's going to be the same as the measure of this angle. You just have to be careful with the fact that that angle would have to be negative, because to be in quadrant 4 it would have to be negative. So what can we do? Well, one thing we can do is we can find the supplement of this angle. So if I ignore the sine, it's going to be pi minus 4 pi over 5, which is going to be pi over 5. But the problem is you need to be very careful. This angle would have to be negative, because this angle is 4 pi over 5. If you ignore all the directions, but this angle here is also 4 pi over 5, but would have to be negative. Okay? Or another way you can do that is you can take negative pi minus negative 4 pi over 5 here, which will give you negative pi over 5, and this gives you precisely what you want. So either way you do it, it's negative pi over 5. Okay? I hope this was helpful.